So,
thank you. Good afternoon. So first I'm going to tell you a little story about jealousy. About an hour ago, that introduction was much, much longer, talking about all sorts of accomplishments of the speakers. So, I'm jealous about that. I also saw a lot of people with their cell phones getting ready to take pictures of him, and I don't see any of those yet. I think afterwards he actually got a few people asking for his autograph, so you guys have a lot to live up to. But who out in this crowd has flown a drone before? Just by the raise of hands, just a few. So it's not too many, so I can say pretty much anything I want, which is nice to know. So my name is Randall Warnas. I'm the Global Sales Manager for the UAS division at FLIR. Today I'm going to talk to you about the industrial applications of drones and how aerial thermal imaging is being used in the workplace. With millions of drones sold each year, tens of thousands of pilots are using them commercially. And so today I'm going to show you a collection of videos and photos that I've compiled through a collection of partners to basically show you how they're actually being used in a number of industries. So the real benefits of using aerial thermal imaging can be broken down into these three categories. So first is the unique vantage point that it provides. This is a bird's eye view, giving you a perspective that you likely couldn't get otherwise unless you had a manned aircraft like a helicopter, which can be expensive and not as flexible. The next is the safety benefits that you can get, and I've broken these down into two sections. First, heights. So if you could reduce the number of times that someone has to climb up a ladder or a power pole or climb on a high-pitched roof, that obviously has some safety implications. And also the environment. And what I mean by this is that you can keep someone from moving through rough or rugged terrain. You can also keep personnel away from operating where there's heavy machinery, such as in mining and construction. And also for public safety purposes, obviously you can keep someone away from dangerous areas before they've been fully scoped out. And then there's also efficiency benefits. If you can reduce the amount of time that it takes to do a certain inspection, there's obvious benefits in that. And the money aspects are, for instance, using aerial thermal imaging, you can increase the power that's generated in a solar field. Or you can increase a farmer's harvest at the end of the crop yield season. Or you could potentially give a longer longevity to infrastructure by doing frequent inspections and maintenance. So the industries we're going to talk about are as follows. Public safety, which is going to be broken down into firefighting, law enforcement, and search and rescue. We'll talk about transportation, which is largely going to revolve around railroads. Surveillance, agriculture, where I'll touch on farming and ranching. Utilities, both power line and solar. Building inspection, looking at roof inspections, oil and gas, archaeology, and wildlife preservation. So, as you can see here, it probably doesn't take aerial thermal imaging to tell you that this building is on fire, but what is interesting is that this video can be sent back to a command and control center where you can have an expert that's making determinations of how best to fight the fire. They can also see if there needs to be more units deployed out to the space to more adequately fight the fire, or if they need to send out specialized equipment. And this is all being documented so that you could use real-life scenarios for training in the future rather than just using standalone training subsets. And this is all being done without a cameraman on the ground getting in the way and also being exposed to the dangers that are firefighting. So this is one way that it's being used and is quite critical. I'm not sure if this video is going to play without someone clicking it, so I'm going to try, and it's not. So could you play that video? Okay, so on the right-hand side, you can see that there's a hot spot, and to the naked eye, this would look like just shingles on top of a roof, but we'll get back to that. When you're fighting a fire, a structural fire like this, oftentimes firefighters will go on top of the roof and cut ventilation holes with a chainsaw. And the reason for this is that they're allowing smoke and other toxic gases to be released through the roof of the structure so that they could better fight the fire from within. So here you can see two firefighters cutting another ventilation hole in the roof. And because this is being piped back to that command and control center, they can assess the techniques that they're doing. They can see the status of the progress that they're making in cutting these holes. They can also use it for training. And this is all while being able to ensure the safety of their firefighters. So if anything were to happen, this is automatically being sent back to a command and control center that's able to make determinations of what to do next. Now I mentioned that hotspot before, and after they pull back down so that you can see that hot spot. This is, again, a problematic area where the fire has not penetrated the roof yet. So if they're able to address this before that actually happens and you're able to identify this with thermal imaging, that could be save a decent amount of property, not only heirlooms or things that are inside, but also the structure itself. And it's right under a tree, which if ignited could cause greater issues. Could you start this video as well? All right, so in this case, the structure had all but burned down, and they flew a drone above and looked straight down to look for hot spots. And they could find that there was heat being captured or trapped within these walls. So they sent out, deployed 2 firemen to break down the wall with an axe and a hose. And the important thing about this is that they're making sure that this building no longer poses a threat. So it's reducing the likelihood of reignition of the fire, but it's also making sure that if anyone is to walk through this building, say the insurance adjusters, law enforcement, other firefighters, or the homeowners themselves, that they're not going to be exposed to a potentially hazardous issue. There are more than 30,000 fire departments in the United States alone, and they're responding to a call about once every 22 seconds. So any tool that you can add to their arsenal to make firefighting easier and safer is an obvious choice for them. So next we're going to move to law enforcement. Law enforcement is using thermal imaging and drones for a lot of reasons, and a lot of times these videos are difficult to get. But in this case it's a canine training video. They sent an officer out into a wooded area, and he went in between a quarter to a half mile away and was hiding. And they're using what's called isotherm, which is you basically set a parameter. Here it's probably between 80 to 100 degrees Fahrenheit, and everything that falls within that parameter is popping out of the screen where everything else is grayscale. So you could see that the drone clearly found the guy, and it took about 2 to 3 minutes for him to be located. Again, he was a quarter to a half mile away, and shortly I think the dog will identify him as well, and we'll wait for him to get his reward, and then we'll move on to the next video. So in another case in law enforcement, and if you could play this video as well. So here, this is taking advantage of the drone's unique vantage point that it can achieve. So here you could see a gentleman standing in between a bush and a wall. It might be a tree and a wall, and was hiding there for quite some time. And so the drone pilot can radio over to the rest of the squad that's on the ground and indicate where he is, and then fly above him. And they're actually shining lights on him, maybe a laser or something to indicate that he's been seen, so that he's more willing to give himself up. But this could be used as a deterrent and also a way to make this process much easier. So once the rest of the troops have been radioed over, in a second you'll see led by another canine unit and a few officers that they can go to that area and take care of the situation. And again, this is without putting a cameraman on the ground. You're getting valuable training assets, and you're able to document the situation if anything is to come up afterwards. So extremely powerful tool in law enforcement. Next, we're looking at search and rescue. Now, search and rescue is probably the most highly demanded use case for aerial thermal imaging. I think the uses are quite clear. But often, most search and rescue instances are happening in remote areas where there is quite rugged, rough terrain. And so the drone can fly over the canopy of trees, moving at quite high speeds to locate a fallen hiker or a Boy Scout. And this can all be done in the dead of night and through the canopy of trees. So it's a really powerful tool in that regard. Now, since 2013, 59 lives have been saved using consumer drones. And of those 59, 38 of those have happened within the past 10 months. So we're seeing a huge amount of demand and a rise of use cases in search and rescue. And it's a part of this push to take the concept of drones from a toy into a tool and show good applications like this, so that regulations and things of that nature can be pushed favorably towards those that are piloting them. So next we'll look at transportation. Around the world there's 850,000 miles of rail track, and this would circumnavigate the globe about 212 times. The United States Railway is about 20% of that. And how aerial thermal imaging is being used is you can use it to do train inspections, where you can determine if there's mechanical errors like air hoses that have been disconnected. You can also do inspections on vital infrastructure such as bridges and communication towers. But probably the most important use case in the rail space is surveillance. In the United States alone, $30 billion are stolen from train cars each year. And so how they're using this is they're basically inspecting the train yard to make sure that there isn't any unauthorized intruders. And this step can lead to higher prices for consumers, but also is the largest death and injury relations to the rail industry, those that are on rail property without authorization. So also can be used as a deterrent, and once you have documented cases, there's less likely for people to be entering into these spaces if they know that it's being well surveyed. So talking about surveillance, this is another drill. An officer jumps over a fence into a gated community, and they turned all the lights off, and basically he was hiding in different areas to see if the drone could see him. Now, in some instances, there are drone manufacturers and service providers that are creating an autonomous system where you basically set a perimeter around a corporate campus or a port or something like that. And once something triggers or goes through there unauthorized, goes through this perimeter, that it'll deploy a drone automatically and identify subjects and follow them. So with this data, you're able to know the point of entry. You're able to know how many people are involved. You're also able to know if they go into any buildings, where they went into the buildings, and how many people went into the buildings. So this is creating a safer environment for security officers, police officers that might respond to the scene, and is becoming more prevalent, like I said, in ports, seaports, and also in large corporate campuses. Next, we're going to talk about ranching and agriculture, and this is just a still, so it's not tricking your mind, it's not moving. But in this case, a professor and an agronomist at Kansas State University were flying above a high-growth wheat field, and this is mid-season. So if you know anything about high-growth crops like corn or wheat, they're very difficult to navigate through, and they cover extreme amounts of space, huge distances. So using a drone, you could fly over these spaces, and what they're looking for here is the amount of water retention within the soil. Water retention in soil is directly correlated to the amount of crop yields that you can get as a farmer. So the dark areas that you're seeing towards the top and on the right-hand side are areas where there's the largest concentration of water in the soil. And where you're seeing the whiter spots towards the bottom is areas that they might consider problematic. So the agronomist can then make an action plan to basically go into these areas and determine whether there's broken sprinklers, whether the irrigation is poor, or if there's some sort of infestation that's causing this amount of dryness in the soil. So this is one area that it's not fully panned out as far as how to use these best in agriculture, but the agronomist in this case said that it is extremely valuable. In ranching, it's pretty straightforward, but this is about a half-mile away from these cattle. And what you're able to do there is you're able to first identify your herd, especially at night or in low-light situations. You can look for strays. You could also identify if there's any predators that have come into the area. And you could do counts of your stock without interrupting or disrupting the animals or getting too up close and personal to them. So for utility inspection, especially power line inspection, this is probably not the most useful photo to show how it's being used, but it is probably the second most highly demanded use case for aerial thermal imaging. And the reason is that even with the advancements of OSHA and safety precautions in the industrial world, there are still hundreds of injuries and deaths each year due to power line inspections. It's considered one of the most dangerous occupations out there. And so what can be done is with the drone and aerial thermal imaging camera on it, you can get up close and personal to each component and make determinations of whether they need to be switched out. This greatly reduces the amount of times that a person needs to climb up a power pole or be on a bucket truck and look at these things and get up close. And they only need to be put in harm's way when it's absolutely necessary to make changes. Now there's a huge push in the world for drone manufacturers and service providers to make this an autonomous situation. So basically you would have a map of all the power lines and drones would autonomously fly down them and basically locate anomalies and send that information back so that you could deploy technicians to address the actual problems. And this would save a huge amount of time and also, like I said, create a safer environment for them to operate. Next we're looking at solar. Solar use is definitely on the rise. Currently the largest consumer of solar power is China, followed by Germany, Japan, the United States, and Italy. And the average solar farm ranges between 1 and 100 acres, and it can be compiled of 100, 1,000, even 1,000,000 solar panels. So currently how these are being inspected is about once every 6 months, they'll take a truck and they'll just have a boom crane arm with a thermal imaging camera, and they're driving up and down the rows looking for anomalies. Again, this is once every 6 months, so it's not very frequent, and it's also very inaccurate. So using a drone, you could set a perimeter around the entire solar farm, and the drone can fly autonomously, taking photos, and basically stitch them together to create an orthomosaic where it's a large map where someone can sit behind in an air-conditioned office behind a desk and look for those anomalies and then send the technicians out to the places that actually need to be addressed. In doing this, you can make these iterations of these inspections not once every 6 months, but you could do it once a week or once every 2 weeks. And overall is going to increase the power output from these solar fields because you're fixing these problematic areas more frequently. In this case, it was a junction box that was broken on that solar panel, and it takes, not too long to fix, but to identify it could have been 6 months where this is basically, these panels were useless. So for building inspection, this is a quick video, so don't blink or you'll miss it, but basically what they're doing is they're flying over a building that's about 100 feet tall, and they're looking for anomalies. So on the right-hand side, you're seeing an area where water had penetrated the deck and needed to be replaced immediately. Without sending a person up there to walk on this roof, whether it was dangerous or not with the water damage, you still are reducing the amount of personnel that are put in a potentially dangerous situation. And you can clearly scan a roof, even a large roof, in a very short amount of time. So for oil and gas, this is a highly demanded use case for aerial thermal imaging, largely because there's a lot of money to be made in it, but it hasn't all been panned out. Now you can see here that they're looking at these pipes that are quite thick-walled steel pipes, and you can still see a huge heat difference inside of it. You can see where the shutoff valve towards the top of it has been turned off, and there's a gradient of where the gas is now cooling because there's no longer gas pumping through that pipe. And the idea is that you could use aerial thermal imaging over the miles and miles of pipeline in remote areas like the Dakotas, Wyoming, Canada, Alaska, and you can do all this inspection looking for leaks without sending personnel, and it would be extremely quick, just like power lines, and give you very valuable data in a quick amount of time. Also, aerial thermal imaging is being used for stack inspection and also for offshore oil rig inspection for the infrastructure. And this is replacing people being harnessed onto scaffolding-like situations. So it's a huge win for the insurance companies and also for the safety of the people that have to do the inspections. So in this video, I'm going to use Hollywood to help me out a bit. This was provided by Treasure Quest Snake Island, which is on the Discovery Channel. I'll let you watch it and then we'll talk about it a little bit. If you could play this video, there's some sound. This one has sound. There should be some playing.
It's going to be the secret weapon.
There we go.
So what we'll do is take it straight up through the canopy. All right, here we go.
The team is using a state-of-the-art drone fitted with a thermal imaging camera that can detect differences in temperature. It gives a bird's-eye view of the jungle and pinpoints any shape, generating a heat signature that varies from its environment.
If there are structures out there, we're going to find them.
Because the rocks will absorb more heat from the sun?
Exactly.
So be careful where you step.
Yep.
Right above you, I can see you and probably about 500 yards around you. If you guys keep heading where you're heading, looks like there's a big clearing right in front of you.
You're a little bit to your right up here.
Right?
Yep.
Actually, hold on a second. I got something right here. That is definitely something. I've got something in a clearing right in front of you guys. It's definitely man-made. It's round. Yeah, I'm right over the hot spots. This is what we're looking for. I'm looking at the remnants of the man-made structure. Guys, time to go digging.
So it's really funny, actually. I can guarantee you that the pilot of the drone was never shown in this video. And also, I can guarantee that they found anything while using the aerial thermal imaging. But the concept is true that if you have the difference of dry soil and soil with rocks or treasure buried underneath, they will have a different thermal reading. So you could use this to plan out an excavation, determine where to dig. So it's kind of a hokey Hollywood way to illustrate that, but it is possible. So Next, we'll step over to wildlife preservation. Ocean Alliance is using what they call their SNOT-bot to do a lot of study on whales. So the SNOT-bot is here on the bottom left-hand side, and basically what that does is it carries a petri dish on top of it. And as they fly above the whale, when it spouts out of its blowhole, it's catching snot on top of this petri dish, and it's using this data, this sample collection, to determine different health attributes of the whale itself. With aerial thermal imaging, they're able to determine the direction of the whale at night, the way that it's moving, because it pushes water, cold water up to the surface. You can kind of see it on the right-hand side, but it's not playing anymore. But that's okay. And you're also able to determine the size of the whale at night when you're using this. They're also using radiometry as kind of a remote thermometer. So when the whale spouts out of its blowhole, they're reading the temperature of that spout and seeing if that data is useful for the determination of the health of the whale. So this is all being used in areas where whales are being decimated by both environmental issues and also by poachers, and so they're finding a huge opportunity for aerial thermal imaging in the whale spectrum. But also, speaking of poaching, Sky IMD and OSA Conservation, and I know that this isn't a drone, but this is a FLIR View Pro that's attached onto a Cessna, and what they're doing is they're flying above the jungle of Costa Rica, and they're looking for fires, cooking fires that are made by poachers that are hunting jaguars. So they can then work with local law enforcement to contain the poachers and make sure that the wildlife is around for everyone to enjoy for many years. So, ladies and gentlemen, the last thing I want to talk to you about is not on the screen anymore. So I don't know why. I wanted to talk to you about orthomosaics, and I guess I can, but the image isn't there. Orthomosaics are basically stitched together thousands of images into one large map. I mentioned that when I was talking about solar panels, but this is also being used in geology. So what would have been there is a large map of a volcano in Nicaragua, and how geologists are using this is they're seeing how the temperature data, there it is. So again, thousands of images stitched together to one big map, and and the cool thing about this is that it's holding radiometric data. So you could basically hover your mouse over any point of this map and see what the actual temperature is of that point. So they're using this data to determine whether the volcano is expanding, and also if there's more likelihood for a near-term eruption. So they're using this data in really exciting ways. The stitching together process is done by Spark Aerial, which figured out an algorithm that is not necessarily commonplace at this point in the drone space, and they're figuring out how to go to market with it, but it's really impressive stuff. So with that said, that is everything that I have, and now my slides won't advance. But I'm Randall Warnas. I really appreciate you guys all listening to me talk about this drone stuff, and I think we have time for questions. Also, I'll be at the FLIR booth 827, I believe, 827 for the rest of the week. If you do have questions, feel free to stop by. I'd be happy to talk about anything drone industry related with you.